Okay, this is asking for I1 and I2. I1 is going to be the current in this loop, and I2 is going to be the current in that loop. There's several ways, or I guess there's two different ways to solve this using mesh or using I guess there's several ways to solve this. But I'm going to use the mesh analysis to solve it, because that's the easiest. And with the mesh, first you assign directions or polarity for your current. I chose to assign the current entering negative and leaving positive. Whatever you assign, it doesn't matter, but whatever you assign, you have to be consistent with both loops. So for the first loop, I have current entering negative, leaving positive. Current entering negative, leaving positive. So for this loop, that's consistent. And then you have to do the exact same polarity for this one. I have current entering, because it's clockwise, entering negative, leaving positive. And these are the polarities were already given for your voltages. Which, if you don't know, this is positive and negative. Positive, negative. Okay, for loop 1, we can start anywhere, but I chose to start here. I choose, when I like to use the sign that's leaving to determine the polarity of my voltage. So entering here, we have leaving, we have negative. So I have negative 10. Entering, we have negative, leaving positive, so we have positive voltage here. So that's plus 4 times current, I1. Same thing here, we have negative entering, leaving positive. So plus 8 times I1. And we also have this I2 acting on this to influence the voltage. So we have to factor that in. And since we're looking at the voltage from the perspective of this loop, so this current is going in this direction. So this direction, the current is entering positive and leaving negative, according to this perspective of this loop again. So we have 8 times the current, or negative 8 times the current of I2. Again, because the current in the perspective of this perspective of loop 1, we have I2. So basically, it's not, you only assign the polarities, and they only get applied if you're applying it to that loop. So entering positive, leaving negative, we have negative 8. So that's the entire equation for loop 1. Now if we go to loop 2, let's delete this. We assigned entering negative, leaving positive, so we have negative. We have negative and plus. There's only one element in that loop, so now we can get the equation here. We have I1. We have starting here, we have entering negative, leaving positive. So we're going to have plus 8 times I2. We also have I1 acting on that element. And according to this loop, I1 is entering positive and leaving negative. So we have negative 8 times I1. And then that gives us the voltage for this. And then this is entering negative, leaving positive, so we have positive 20. Now we have two equations, and we simplify this, combine like terms. We have I1 here. So that combined into this, and you can use substitution, but I chose to use matrix because I'm just used to using that. And to get the matrix out of these, you group your like terms have to line up. So your I1s, my I1's lined up here, my I2's lined up here, my voltages lined up there. So we take the left hand side of the equation, which was the coefficients 12, -8, -8, and 8. That's the determinant of the denominator. We have 12 times 8 is 96. -8 times negative, or 96 minus -8 times -8. Remember, when you're multiplying in that direction, you apply the negative up here. So that equals 32. And now we can solve for I1. Replacing I1's column with the voltage here will give you I1. So what we did was input this voltage column into this, or replaced this I1 column with the voltage column. In doing that, we get 10 times 8 and minus 20, -20 times -8. And that equals 8 minus 160, which gives 2.5. And that's amps. And we do the same thing here, except for we want to solve for I2, so we replace the column I2 with the voltage, which is what we did here. 12 times -20 equals -240. Now -8 times 10, and again we have to add that negative. You have to add that negative here, so it's really -8 times -10, which gives a positive 80. And we get this and solve for that, we get 5 amps, -5 amps. And the negative represents that, it basically tells me that the direction of the current that I chose was wrong. So to get the correct flow of the current, you just reverse it, and that's the correct direction. And that's what it asks you to solve. If it asks you to solve the current, for example, if it asks you to solve the current in this node, basically you have to look into that node. I assign my currents clockwise, so according to the 8 ohm resistor, I1 is entering that node, and I2 again is going clockwise, so it's going away from that node. So basically the current here is going to be anything leaving this node is negative, anything entering it is positive. So I1 is entering, so that's positive, and I2 is leaving that node. So I1 minus I2 will give you the voltage, the current here. And I1 minus I2, -2.5 minus -5 equals 2.5 amps. So the current and that leg is just 2.5 amps.